Okay, today we're going to talk about vertical motion problems. Some of this stuff is already going to be familiar to you. We've talked about this before. We talked about the position function previously when we were talking about derivatives. And so the position function is given here. S of t is equal to negative 16 t squared plus v sub 0. And actually, there should be a t in there. V sub 0 t, v sub 0 t plus s sub 0. Okay, and that negative 16 would be used if your measurement is in feet. So this is your feet per second. If it was meters, then you would use negative 9.8 as your number there. But this is a function that we've actually used before. And similarly, then we talked about the derivative. The derivative of the position function is the velocity function, and if I take the second derivative of the position function, which is the derivative of the velocity function, that gives me the acceleration function, So we started talking about integration and we said and antiderivatives, and we said it was basically undoing the derivative function. So I'm going to show you how we use that when we are working with vertical motion problems. Well, here's a problem that we have. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. And it says find the position function giving the height s as a function of the time t. Now, it's obviously seen that we can just plug into that this equation that we have here. But I want to sort of show you how we could potentially get this function if we didn't have it to start with. Now, obviously, we could just plug in our initial velocity and our initial position and get that. But I want to show you how this works with integration because there's going to be other problems where you're going to have to use that. Okay, so let me show you how this would work. First of all, our initial time, so this is part A, our initial time we're going to call t equals 0. Makes sense, right? We also know that our initial height, because they gave us that in the problem, is 80 feet. And we also know our initial velocity is 64 feet. Okay, so those are some things that they gave us. Remember, the derivative of the position function is the velocity function. Because we're dealing with feet, we know also that our second derivative of our position function, that would actually be negative 32 feet per second. Now, in the formula you saw negative 16. That's because we take half of this when you actually do out that formula. Okay, so that's why it says negative 16. We're talking about acceleration as negative 32 feet per second. And that's just something that is a known entity whenever you're dealing with gravity and free fall. It's always negative 32 feet per second. Okay, so if we start, let's start from there. I know the acceleration function, or the second derivative of the position function, is a negative 32 feet. And from there, if I go ahead and take the antiderivative of that, it'll give me s prime of t. Okay, so what I'm saying is this: s prime of t is the same as taking the integral of s double prime of t dt. And so if I go ahead and substitute in, I end up with negative 32 dt, which would then give me negative 32t plus my constant c. I'm going to call that C1. I don't need to call it C1. I just want you to recognize the different C's where all these different c's are coming from. If I just called it c, that would be fine as well. Okay, so I have then that s prime of t is equal to negative 32t plus c. Actually, I'm going to take the 1 out because we actually don't really need it. Let's just leave it as c. Okay, now the bit of information I have here is this, that s prime of 0 is 64. So if I set this, if I do s prime of 0, that would give me negative 32 times 0 plus c is equal to 64 because that's the information they gave me over here. And so when I solve for c, then I would get 64. And so my s prime of t, or my velocity function, is then negative 32t plus 64. Okay, so now I have my velocity function. Now, from there, I can actually get my position function by just taking the integral of my velocity function. So negative 32t plus 64 dt. And now we talked yesterday about the different properties having to do with integrals, and we said, well, when you're adding, you can just take the integral of each of those. And you don't need to write out the step of taking the integral of each, because it is something we know that you can do, so you can just go right from this step to doing that. And that would give you negative 32t squared over 2 plus 64t plus c, which would then give you negative 16t squared plus 64t plus c. And that's going to be our position function. Okay, that's our position function. I'm just going to move on to a new screen here, so I'm not cramming everything on. Okay, so we had s of t. What we just found was s of t is equal to negative 16t squared plus 64t plus c. And we were given in our problem that s of 0, so right here we were given that s of 0 is 80. So I'm going to use that to my advantage. I'm going to say, okay, well, s of 0 is going to be negative 16t squared plus, negative 16, getting ahead of myself here. Negative 16 times 0 squared plus 64 times 0 plus c is equal to 80, and so we know that c is 80. And so we know then our position function is negative 16t squared plus 64t plus 80. Now, remember what I said in the beginning was we could have just plugged in our initial velocity and our initial position into this equation to get that position function because they gave us those parameters in the problem itself. Right? They gave us our initial velocity and they gave us our initial height. And we could have just plugged it in and we'd be at the exact same place that we are right now. Which is great that we can do that. I just wanted to show you the steps of working backwards through this problem because there will be some problems where you're not necessarily given those initial amounts. You might be given velocity and you have to integrate or take a derivative to get the different pieces and parts. Okay, so I just wanted you to be aware of how we go about doing that. Now, in part B it says, when does the ball hit the ground? Well, the ball hits the ground, right? When the ball hits the ground, its height is 0. So if I go ahead and set this equal to 0, I can figure out what t is, and that will tell me the time at which it hits the ground. Okay, so if I go ahead and factor, I can factor out a negative 16, and that leaves me with t squared minus 4t minus 5 is equal to 0. And that would give me negative 16 times t plus 1 times t minus 5. And if I solve both of those, I get t equals negative 1, t equals 5, and we can't have a negative time, so I know that at t equals 5 seconds after the ball is thrown is when it will hit the ground. That's how you approach one of those problems. I will be giving you a link to another video so you can see another problem and see how that's done. Alright, thanks. Take care.